Now let's look at limits at infinity. The definition of a limit at infinity is if f is a function defined on an interval from some point a to infinity, the statement the limit as x approaches infinity of f of x is 0 means that whatever positive number I pick, there is a corresponding n such that f of x is greater than m whenever x is greater than n. And similarly for the limit as x goes to infinity of f of x is minus infinity. Basically, all this means is f of x becomes unbounded. We are going to treat infinity like it's a number, even though it's really not, but it is a nice shorthand. Remember, all of mathematics is just a shorthand. So let's look at this function right here. What is the limit as x approaches positive infinity of x cubed? We can see it becomes unbounded in a positive sense. So we're going to say this limit is positive infinity. What about the limit as x goes to negative infinity? Well, if I can see that this becomes unbounded again in a negative sense, and so it approaches negative infinity. Now here's where we have a little bit of fun. What do you do if you take this limit as x approaches infinity? We have a polynomial in the numerator and the denominator. The numerator becomes unbounded much faster, so this is plus infinity. What about when x goes to negative infinity? Well, we can see there are a couple things you can do here, and if I look at this, if I just look at the leading coefficients, I see that this becomes 2 times x, and this becomes negative infinity, but that's not a very rigorous way to do these. So I'm going to do something called, well, I'm just going to divide the denominator into the numerator, and I'm going to rewrite this, because it turns out we have a slant asymptote, which this may help you out a bit. X goes into 2x squared, 2x times. 2x times x is 2x squared. 2x plus times 1 is plus 2x. Now I subtract, so that's 0. So this becomes negative 6x. X goes into negative 6x minus 6 times. Negative 6 times x is negative 6x minus 6. Subtract. So I have 6. So this is plus 6 divided by x plus 1. So now let me take the limit of this. The limit as x approaches infinity of 2x minus 6 plus 6 over x plus 1. We can see this goes to 0 very quickly. So it turns out we have a slant asymptote of y equals, now all we're going to do is take this part right here, not the fractional part, 2x minus 6. So this limit is the same as the limit as x approaches infinity of 2x minus 6 or plus infinity. Now the limit as x approaches negative infinity of 2x minus 6 is minus infinity. So slant asymptote is going to help you out there, and you're not guessing.